CERN, which stands for the European Organization for Nuclear Research, is one of the world's largest and most prestigious centers for scientific research. It is located in Geneva, Switzerland, and is home to some of the most advanced scientific equipment and facilities in the world. CERN has been at the forefront of groundbreaking discoveries and scientific marvels that have pushed the boundaries of our understanding of the universe. CERN is one of the world's leading research centers for fundamental physics, and its biggest impact is due to great scientific discoveries. The Large Hadron Collider and other unique facilities at CERN provide the necessary infrastructure for scientists around the world to gain more knowledge about the smallest constituents of matter, their interactions, and the origin and evolution of the universe. After marvels of vast knowledge and experimentation, CERN is back in the spotlight for what could be the recent greatest discovery ever made in defining and exploring the possibilities of other worlds. You see, thinking of other connecting dimensions, and in fact other dimensions, are what fascinates all of us watching this video. That's what brought you here, right? So let's dive into what the CERN scientists have discovered. Have they really found a way to open a portal to other dimensions? You will get to know this and plenty more as we dive into details. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. Introducing CERN. Since the organization was founded in 1954, the discoveries and measurements of the W, Z, and Higgs particles and other phenomena have dramatically improved our understanding of the fundamental physics. 3 CERN researchers obtained Nobel Prizes in physics: Carlo Rubbia, Simon van der Meer, and George Charpak. The discovery of the Higgs boson by the ATLAS and CMS collaboration led to the Nobel Prizes for Peter Higgs and François Englert. At CERN, about 70% of the world's particle physicists work together on one of the biggest scientific endeavors in the history of humankind. They use the most complex scientific instrument on Earth, the 27-kilometer-long Large Hadron Collider, LHC, to study nature's most basic constituents and address questions like, what is the composition of the dark matter, making up 25% of the universe? Why is the universe only made of matter, with almost no antimatter? The LHC accelerates and collides protons or lead ions to produce conditions that give new insights into the earliest moments of the universe. Complex detectors the size of 6-story buildings record billions of collisions per second, and scientists across the globe use the worldwide LHC computing grid to analyze the data. Every year, researchers at CERN publish about 900 original research papers in peer-reviewed journals. In addition to the LHC, CERN provides a number of unique research facilities and experiments to researchers around the globe, including the Anti-Proton Decelerator, for precision experiments to understand if matter and antimatter behave in the same way, the ISOLD facility for studies of nuclear physics using a wide range of exotic nuclei, and the CLOUD experiment for exploring the influence of cosmic rays on cloud formation in the Earth's atmosphere, giving an important input to global climate models. CERN's theory department have been the source of many ideas that have contributed to reshaping our understanding of nature, such as supersymmetry and supergravity. Today, physicists in the theory department continue to propose original ideas, contributing to CERN's visibility and inspiring the general public. While CERN's research is primarily motivated by curiosity, its impact on society and everyday life is significant. Reaching ambitious scientific objectives requires the development of advanced instruments and new technologies, making CERN and the collaborating institutes and laboratories drivers of innovation. This brings tremendous benefit to society and the economy through knowledge transfer. CERN is the powerful model for international cooperation. About 16,000 scientists of more than 110 different nationalities work together effectively and peacefully toward a common goal, regardless of ethnical, cultural, political, or religious differences. The history of CERN has shown that scientific collaboration can build bridges between nations. CERN contributes to improving science education from secondary school to postgraduate level and to a broader understanding of science by the general public. Many of the young physicists, engineers, and technicians trained at CERN transfer their expertise to other research projects, to industry, or to society at large. CERN engages in many ways with citizens from across the globe through a variety of outreach activities. Learning about the fundamental constituents of the universe and how scientists try to answer fascinating questions inspires young people and increases their attraction to science and technology. LHC. Now let's get back to the Large Hadron Collider. If you've seen the movie The Flash, you might be aware that the particle accelerator that gave rise to the Flash's lightning storm of dark matter gave him his super speed. However, despite the fact that the LHC and this particle accelerator both accelerate particles to high speeds before colliding with them, they are two very different machines. The LHC is a fictitious gadget that operates on the principles of superhero comic book fiction, whereas the Flash's particle accelerator is a real-world scientific instrument that operates on the principles of particle physics. The Large Hadron Collider, LHC, is the largest and most powerful particle accelerator in the world, operated by CERN, European Organization for Nuclear Research. It is a circular machine located on a tunnel beneath the French-Swiss border near Geneva, Switzerland. The LHC consists of a 27-kilometer, 17-mile ring of superconducting magnets and accelerating structures designed to accelerate and collide particles at extremely high speeds. The construction of the Large Hadron Collider, LHC, was a massive undertaking that involves the collaboration of thousands of scientists, engineers, and technicians from around the world. Construction began in 1998 and was completed in 2008, with a total cost of approximately 6 billion Swiss francs, equivalent to around $7 billion at the time. The construction of the tunnel required extensive excavation and drilling, and the magnets and accelerating structures were carefully designed and constructed to exact specifications. The LHC is a complex machine that requires a large amount of infrastructure to operate. This includes cooling systems to maintain the superconducting magnets at extremely low temperatures, power supplies to provide the necessary energy to accelerate the particles, and computing systems to manage and analyze the data generated by the experiments. Despite the high cost of construction and operation, the LHC has been a tremendous success, producing groundbreaking discoveries and advancing our understanding of the universe. The cost of the LHC has been offset by the many benefits that it's provided, including advancements in technology, medical imaging, and our understanding of the fundamental nature of the universe. As mentioned earlier, the Large Hadron Collider LHC is a particle accelerator that works by using powerful magnets to accelerate beams of particles, such as protons or heavy ions, to almost the speed of light. These beams of particles are then directed into a collision course with another beam of particles traveling in the opposite direction, causing them to collide at very high energies. The LHC consists of a 27-kilometer, 17-mile ring of superconducting magnets that guide the particles around the accelerator. These magnets are arranged in a series of arcs and straight sections which are designed to focus and accelerate the beams of particles as they travel around the ring. The particles in the beams are initially injected into the LHC from a smaller accelerator and are gradually accelerated to higher and higher energies as they travel around the ring. The beams of particles are kept on their path by magnetic fields produced by the superconducting magnets, which are cooled to extremely low temperatures to allow them to conduct electricity with zero resistance. When the beams of particles collide, they release enormous amounts of energy, creating showers of subatomic particles that can be studied by scientists. The detectors at the LHC are designed to capture and analyze these particles, providing valuable data that can be used to better understand the fundamental nature of the universe. The LHC is capable of generating extremely high energy collisions, allowing scientists to study particles and interactions that are not observable in everyday life. The LHC has achieved many groundbreaking discoveries and advancements in particle physics since it began operation in 2008. Here are just a few of its achievements. Discovery of the Higgs boson particle. In 2012, scientists at the LHC discovered the Higgs boson particle, which is responsible for giving particles mass. This discovery confirmed the existence of Higgs field, which had been hypothesized in the 1960s. Confirmation of the standard model of particle physics. The LHC has conducted numerous experiments that have confirmed the validity of the standard model of particle physics, which is the most widely accepted theory of the fundamental particles and forces that make up our universe. Exploration of dark matter. The LHC has conducted experiments aimed at detecting dark matter, a mysterious substance that makes up a large portion of the universe but cannot be directly observed. These experiments have helped to refine our understanding of the nature of dark matter. Advancements in medical imaging. The LHC's technology and expertise in particle physics have led to advancements in medical imaging, such as the development of PET scanners, which are used in the diagnosis and treatment of cancer and other diseases. Overall, the LHC's work has had a profound impact on our understanding of the universe and the physical world. Its discoveries and advancements have pushed the boundaries of science and technology and have the potential to lead to even more groundbreaking discoveries in the future. On July 7th, a puzzling crack in the Earth's magnetic field surfaced. This enigmatic fissure didn't arise out of thin air and disappear in a flash. It was open for at least 14 hours. Strong geomagnetic storms and an amazing sight to behold were brought on by the split in the Earth's magnetic field, which allows solar winds to rush through the gaps. But how did that crack suddenly appear? The researchers claim that this occurred as a result of a rare phenomenon known as a counteracting interaction region from the sun. Large-scale plasma structures like these are produced in the lower middle latitude areas as a result of interactions between distant solar wind streams and the local slow solar wind. In addition, since the first phase of the Large Hadron Collider project was initiated by CERN, the LHC has found a total of 70 new hadrons. What's with portals? Many people have theorized that the group is attempting to create portals to the black holes in different dimensions. Others have even gone so far as to assert that CERN is creating a portal for devils to join our universe. All these assertions and misconceptions, however, are purely untrue and false. A physics professor at the University of Buffalo explains in a statement why current technology, including the collider, cannot access black holes. Several others also think that the Large Hadron Collider might create a doorway to a parallel dimension from which they will be unable to escape. Once the Hadron Collider was restarted in 2022, some people even think that now we reside in the parallel dimension. Many of these issues were raised by Max Laughlin, a young man with extensive knowledge of particle and quantum physics. We had an original timeline, he claimed. But as soon as the experiment's anomaly occurred, we were infinitely catapulted into a countless number of parallel universes. These safety concerns and the potential for creating a black hole prompted a protest against CERN, where a number of people began calling for the LHC to be shut down. But CERN researchers have kept up on their investigation and are satisfied with the security of their work. In response, a number of academics and researchers spoke out expressing their faith in the Large Hadron Collider. Finding out about a puzzling fifth force of nature is the main objective of the most recent run of the particle accelerator. Although the researchers think it exists, its enigmatic fifth force has the power to fundamentally alter particle physics dynamics. Also, scientists are attempting to learn more about ghost particles, sometimes known as neutrinos, and dark matter particles. Neutrinos particles are comparable to electron particles but lack a charge. They are created at the cores of stars. The Hadron Collider will soon be upgraded by the CERN by increasing collision energy, brightness, and better detectors. After the Lumosity renovation, which started in 2018 and is scheduled to be finished in 2027, the Particle Collider will aid in improving the visualization of rare processes. The present run would conclude in 2025, and CERN would turn on the LHC for a probable fourth run in 2029 after a potentially lengthy pause. The fourth run would continue until 2042 with the collision rate 10 times higher than the current one, assembling a gigantic dataset that is 10 times larger than the third one. What is the nature of Higgs boson, for example, is one issue that researchers hope to find answers to. Exist additional particles to the standard model? What type of substance is dark matter? Can we solve the antimatter puzzles? How we live in the future may be completely changed by the answer to these issues. In addition to be fascinating, CERN's discoveries are crucial to our comprehension of the cosmos. With that, we have reached the end of today's never-ending portal. Would the LHC be able to answer all the above-mentioned questions? Do let us know in the comment section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.